Hello, everyone. Welcome, Fernando. We're going to talk here about Windows containers. Are you interested in that, Fernando?
Oh, yeah, sure. Thanks for having me here. This is a good topic now because I have experience modernizing Linux applications using Linux container. And now I have a project to work. I have a legacy Windows application that use IIS. And I would like to do the same thing I used to do in Linux, but using Windows, make the application faster to deploy, containerize like in small piece of software to allow in the future deploy it on Kubernetes and scale the components on demand. The components I need to scale to only scale that components, but this will be the next step. Today, we are going to start showing how to containerize a Windows application to run a container, right?
Yep, that's it, Fernando. We're going to look on the first thing, what the developers need to starting, modernizing the applications that are using, full .NET framework. That's the only option for them is to run that on Windows. And they normally use on Windows Server with, IS. And how can we modernize that and you start using Windows containers to run those applications? Then you can start breaking those applications in like APIs, microservices, and it'll be easier to scale and it'll be very interesting, for the future move to .NET Core. And I think the first step is move these to cloud native using containers. And if you're going to use, Azure in the future, you're going to start integrate with some Azure service. And the first step here that we're going to talk, let me share my screen. We have a video that you help us to make. I can show here. There's a nice video about there's even a playlist. Okay, that's a playlist about containers on our channel, Azure. And that video set up Docker desktop. I think the first thing that, someone work with containers, they have to do it. We're not talking about on Windows containers on this video, but now, this video will be the complement for this one. Once you have installed, Docker desktop, because that's a main requirement, you're going to have Docker desktop like this one installed. You can see next to your clock here, you can see Docker desktop, that whale. And if you click settings, you're going to open that, or dashboard. If you close the settings, you can see the dashboard. Okay, that's what we call Docker desktop.
As in Jorge, remember in this screen, the default, it installs for Linux containers. So you have this switch to Linux containers here will be switched to Windows containers. This is the first requirement to work with Windows containers.
Correct. Normally, when you start Docker desktop, they are on Linux containers by default. Then you have to come here and there will be an option switch to Windows containers. That's I have done already. Now I can just switch back, but I'm already running Windows containers. Okay. Then the first thing is make sure that you switch to Windows containers. And that's my Windows containers. I can see the settings here. Okay, I can see my Docker engine, every source. The only thing is pretty much only Windows containers. I can see much on Linux here. The only thing I can see now is the container image that I have. I can even increase the screen here a little bit. You can see that I can see my containers running. I don't have any. And I can see the Docker image that I have. Okay, that's the first environment that I need to work with containers. If I open my my shell here using Windows terminal, the new Windows terminal, and if I clean up and I do again Docker image, I can see the same thing that I can see here on my Docker interface, user interface. Okay, now I can even run containers from here. That helps a lot if you don't know much, about the user interface.
As in, remember, this is the Docker Edge version.
That's the Docker Edge. I think the current version is already including that, Fernando.
Oh.
I think was already released on the stable version. But, for example, I could run that container, and even they let me setting some ports. Say I wanna run these on port 81 on my machine. That will be port 80 inside the container. I can even map volumes from here.
Okay, this is a great improvement.
It's a great improvement because you don't need the command line. You can just go here. I want this, call this a container called test, port 81, run, and then we should be able to see this running soon. Yep, there you go. Container is running. You can even open that in the browser. Okay, because that's application demo that I did. We're going to see that application soon. That's running on port 81 like I asked for, because I don't want to run on my port 80. I have other things running on port 80. And if we wait a little bit, because that's how Windows containers using IIS, it'll take us a few seconds to start up, to warm up. Then, but you can see that Docker desktop now, yep, you can see that's already running. And I did everything just using the Docker, user interface. That's pretty nifty. And the nice thing here, you can even open the CLI. Look at this. I'm inside the container now. And that's my application inside, www roots. That's the application that I deployed that was inside my Docker image. That's my container.
It's awesome.
That's Vivian file. I can stop the container, I can restart the container, and even delete from here.
So now you don't need to know how to use the CLI. You can use everything from
the CLI is like Docker PS. You can see the container is running there. Okay, you can see the container running. And a nice thing here on the Docker user interface is that you can click in your application and you can see the logs. You can see that IIS is running. You can even do a spec that I was doing on the command line. You can do here. Okay, you can get the stats. Look at this. You asked me how much memory the container was getting.
Oh, this
700 megabytes to run a full, ESP.NET container. And that one's already running for a while. But
this is already stabilized.
Let's get a Linux one, how much memory I'm using, 200 megabytes only to run a Linux container on Windows. And CPU, look, nothing. You can see that's Nginx version that I'm running because I got environment variables. And you can see the logs for Nginx. You can even stick here to the bottom or just pop up. Okay, and on the container, if you open, you can open here, but you can also open the command line.
Inside the container?
Yeah, inside the container, if you do. You have IP config here. Yep, you can see the IP of the container. And then, say one interesting thing, if you go here and you put the IP, you can see the same, because this is the IP direct to the container. You don't need the port number. The port number is just like a routing from your host, in this case, Windows 10, to the container. But if I get the IP number, I can go straight there.
So, Jorge, and what about this new feature, the process isolation we have in the Windows 2004, Windows 10 2004, that was previously available only on Windows Server?
That's a good question, Fernando. Then, if you remember that discussion here about process isolation, you can on Docker you can use that flag isolation process. Okay, I'm using just like a server called 2004. That's the first version where you have to have your host, like your Windows, updated to version 2004 plus to be able to use process isolation. But if you have that like I have, you can run. I'm running like an interactive container with command line. If I run that, you can see that I'm not creating like a lightweight VM, anything. It's not a Hyper-V container, it's a process isolated container on Windows 10, now possible with 10.04. And I'm inside the container here. So if I go out.
This works like the Linux container used to work on Linux, right? We are doing the same thing on Windows.
We're doing the same thing as Linux does on Windows 10 now. What's possible on Windows Server, but not on Windows 10. And 2004 is the first version where that's possible. And I just created here, and you can see the container is running. And even if I go for the Docker desktop, I haven't put a name. That's why I put like this random name. And if I go CLI, it's running process isolation. What's the difference? Many people different. The difference between process isolation and Hyper-V, if it's a Hyper-V container, you can see that VM, there is a lightweight VM here. It says it's taking like almost 700 megabytes. And if you look at the process isolation container, it's just taking 97 megabytes.
So it's very efficient.
It's very efficient. Okay, there's a few containers here, but it's taking less and less memory than the normal container. I think that's the Linux containers on Windows is taking 100 meg, but it's taking around like 100 megabytes, I think. We can even try here. If you click here, you can see the stats. But there you go, 62 megabytes only.
Oh, it's great.
There's a huge difference if you compare. We cannot compare because it's not the same. That one's just like a 7 core.
Well, we can spin up the same container with another name without this flag.
Yeah, we can. If you do the same, okay, and you say Hyper-V, that's the default. By the way, you don't have to put it, but if you do that.
And as we can see, this is a little bit slower to start.
It's a little bit slower to start. That's going to jump inside the container because I put it interactive. Yeah, there you go.
Done.
See, that's running. I can
check our task manager now. And
now I can check my task manager first. Let's see, there's another container, only
300.
Yeah, 336. You can even check here, by the way. You can check here. 342. And you can check that on price isolation 65. Huge difference. Huge difference. Okay.
I'm keen to see this process isolation running on the Kubernetes cluster with Windows containers. It will be awesome.
Yep. And if you compare with the Linux containers on Windows, you can see that spending less memory than like a Linux container. Linux containers take 100 megabytes, and the Windows container is just taking, that's the, let's see,
process isolation,
85 now. And then very, very interesting to see, the difference and see what's process isolation. Let's go to the next step. How can we have like a Visual Studio? Okay, anyone that work with full .NET framework, they work with Visual Studio. I'm using the latest version here, 2019. I have an application that I created. How I created? Normally, people using full .NET framework. If I create new project here, what they're using? We talk about migration. We talk about modernization. Okay, people already have a solution, a project, but they normally use that one. ESP.NET Web Application C#. If you create a new application like I did it, I'm not going to fully create it. You can pick your .NET framework. 4.7.2, 4.8 now. You can say, I want to create that application. And you can see that you can pick the type of the project. The one that I created before, that I'm going to open that soon, is that one, MVC. If you use MVC, you can see that you can pick like if on a web API as well. And very important here, click Docker support. Once you do Docker support, you're going to have all the integration with Docker done for you. So that's it. And you can even do HTTPS as well. They're going to create self-signed certificates to have full HTTPS from day one. Once you create that application, okay, I'm going to back here because I have that application created already. And I'm going to open that application. I'm using the preview version of 2019. And I'm just going to open that Win container demo. That's my Visual Studio. And I have my Dockerfile here. If you can see the structure here at the right, it's just like a default basic, demo MVC application. And that comes with a default, because I enabled Docker, you can see that there is a Docker file here. The only thing I changed, I'm removing the 2019 Docker image, and I replaced for the latest one, Fernando, 2004. And once you do that, if you click here, you can see there is a button here called Docker. Okay, because I downloaded this image before, it will be faster for me. If you're doing that for the first time, they're going to take a while to download this. It's a quite big image, but once that's done, after the second run, it'll be pretty fast. Then if you click here, run, we should be able to run the same thing that we did before. There's just one thing I have forgot here, Fernando, to do. I'm going to cancel here just because I want to move back to debug. Okay, make sure that you are in debug mode and you run that. What Visual Studio is doing? Visual Studio is doing similar to the Docker Desktop is doing when you do manually. They're going to run the container for us. And they're going to run in debug mode, okay? And you can see that the container is already running. If I go my Docker Desktop, there you go. I have the container running. Okay, I think because I stop and let me delete this one. I don't need that. Just because I stop and create again. And they're running on that port. There you go. Visual Studio is already open the browser in debug mode. They're not using the port number, but they're using the IP, like I showed for you before. And now you are in debug mode. If I go here in my source code, like say controllers, maybe home controller. See, when you click here on about, if I go here back and I click here about, you can see that the debug is working here. And you just go for normal debug, stepping over, and just continue, and your application is running. If you remove the container, then you have a fully, debugging inside the Windows containers on your Windows 10 with Docker Desktop. And one interesting, there are things that you can change here without even stop the container. Say, if I go for my view, let's say my index view, I just put my name here. I don't care. I just want to, I like my name, save, come here, ROM. There you go. You can see my name there. That's a fully operational debugging. You can edit. If you make any change where you need to stop, you can just stop and start again. The way that works, Fernando, they mount, your application folder inside that container. Okay, that container here, you have that mounted. Then if you open the shell again, that's your application here.
Zooming here.
And you can see that's my application, but that folder here, w root, okay, is the folder of my application. If I go here on the source, let's show the source application just a second. Very interesting here. That's my container, okay? That's the files of my container here on the left, and that one is my machine. because I mounted the whole folder here inside, if I come here and I say, just create a text here, okay, doesn't matter. I just want to show that text.txt that I just created here is showing there. I just want to prove that that folder here is the same that you can see inside the container. Means that there is a container volume map in that, and that's how it works. Anything that you change in your local folder runs inside the container, and you can debug because the debug is enabled. And that's how Visual Studio is doing all the magic. If you want to understand a little bit more, I like to show how the thing works, Fernando. Just go on that container thing.
Because and the best thing is this in the same way you are running the application on a Docker container in your development computer, you run this as a container on the server. Exactly the same thing.
Yeah. And then if you go here and output build order, you can see that Visual Studio is building the image for us, the container image, and it's creating the container and it's running, doing Docker run here after.
You can see all Docker commands. You even don't need to know how to use Docker.
You don't need. They're going to create the image, and you can see that the image is in use here. Is that one Windows Win container demo dev? Okay, that's the container that we're using? How I know that? Here, Win containers demo dev, Windows container tag dev. Okay, and that was created.
And how it works when you finish the code? How do you do your final version?
Okay, when you want to publish that's a good question. You just stop here, and you need to build, that container image here called with like a tag called say latest. That's the latest version. You have to go in your code and change that for release. Okay, if you do release and you just run Docker, they're going to rebuild. See, you can see the same thing happen again. They're going to build again. And you can see that they're just using the tag Windows containers. That means that will be latest. They're not to put in dev. Okay, and that was created. If I go back on my container image, you can see the latest was done like less than a minute ago.
Yes, and I'm seeing on this step 4 by 6, there's a copy command. So I think now I can't edit my files inside the container, right?
Yeah, exactly. What happened is on that final image, they're not mounting, your source code. They're just copying your source code. Remember the Dockerfile here? The Dockerfile, that's exactly what they're doing. They're going to get the publish, and they're going to copy inside your container. That dot means they're going to copy to the current folder. That's the www root. Okay, it's just failing because I cannot run because it's just a release. And I'm using the 2004 version. And that's it. You just create now an image, and you can do the same thing I did at the beginning. You can just go here and run your container as a final version. Okay, I run, win test or win container demo could be the name of the container. I want to map 82 now and just run as I did the first time.
You need to wait a few seconds.
When show here, you can just open that in the browser, wait for that to warm up. Yes, and you can see my 81 port still running. I'm doing 82 now. See, the 81 is still running. Okay.
As in, we see the code change on the 81 with your name on the container, right?
Exactly. See, the 81 is the old version. There is no my name here, Jorge, and that one should be showing with my name because that's the version that I changed and I added. There you go. My name's here.
Oh,
Okay, that means
Oh.
that's the new version. That's version 2 after my change, and I publish again and I run that again.
And how it works under the hood?
What do you mean under the hood?
Under the hood, do you have like a presentation about that?
Ah, okay. You want to know? Okay, that's running. Okay, that's how you can get your Visual Studio application. You can just create a Docker, Dockerfile, and you can publish. Visual Studio is doing most of the work for us. Maybe another video, Fernando, we can do like a pipeline on Azure DevOps or GitHub, and I can show how to automate that. But
awesome.
Under the hood, the way that work is, you are welcome to go on Microsoft Docs. There's a beautiful documentation here how that works. One thing is like isolation, okay? And I have a PowerPoint that's probably going to help to show that. Let me open this first. If you haven't subscribed, Fernando, for our channel, that's the time. Subscribe to Azureta channel. And there is azureta.com blog where you can follow us as well, and Azureta on Twitter. We have like more than 55 videos published in English and Portuguese. Please enjoy, follow us, like and recommend for friends.
And activate the notifications to see when you publish a new video. So
for sure. Let's go for straight Windows containers, okay? To not be a long video here.
Right.
Windows containers have in two flavors. We have what called Windows containers and Hyper-V, Windows Hyper-V containers, okay? Normal Windows Server containers and Hyper-V containers. What's the difference? The difference is, assuming that everything today runs on top of like a Hyper-V, of a VM, a hypervisor, on the cloud, even on premise, everything is on top of a hypervisor. Then you have the Windows kernel on the left here. On top of the Windows kernel, have all the Windows process, system process. And now we have what we call container management. Okay, on Windows 10, we're using Docker engine. And Microsoft integrate the Windows Server and Windows 10 with containers. We create something called, compute service, where we integrate, Docker engine or one thing called container D. That's like a library to run containers. That's the Windows user mode where all the processes are. And we create something called Windows Server container. Then a container is nothing more than a process isolation on top of Windows kernel. Okay, the same way that runs on Linux runs on Windows. That's what I call Windows Server. Very similar to Windows containers.
So this Windows Server container is the new thing on Windows 10. We can run in the same mode as a process isolation, right?
That's what we call process isolation. Okay, isolation that I'm going to show on the documentation is process isolation, that left side here, or Hyper-V isolation. What we call Hyper-V isolation is an extra layer of security where I have a very lightweight layer of virtualization. That's why I call Hyper-V. But it's not like a full virtual machine that's optimized, just to run containers. They strip everything out. It's just a few megabytes, just the minimum to run a container inside that. And here inside is the same Windows Server container that you can see here on the left, on top of the Windows kernel. Means that on Hyper-V containers, we have a dedicated Windows kernel because inside a lightweight VM. On the process isolation container, we are sharing the same kernel. Let's say they have a Windows Server with 5 containers running. They all sharing the same Windows kernel. On Hyper-V container, each container will be your independent kernel. Okay. Then the only duplication here is that lightweight VM and the Windows kernel, and that's safer than the normal because there's an extra layer of isolation. Okay. Let's try to compare that, Fernando, with Linux container. The normal Linux container is very similar to that left side here with the process isolation. Okay? The native Linux container have the Linux kernel. You have the same Docker engine that we call Docker D. And I was talking about Docker Container D. Container D is a library that was open sourced by Docker to run containers. More high level library, okay, can manage container image, containers, the container itself, the snapshots, everything's done by Container D. And Run C is the original container runtime, okay? Many people only see that as Docker, but Docker come in different components, and Docker open source Container D and Run C, 2 or 3 years ago. And then Container D is that library that we calls, this Run C engine that's runtime that creates the container. That's how the native container runs. What we did, Fernando, we did a little bit more. We think, okay, we want to run Linux containers inside Windows as well. Okay, the Windows container is not just for Windows; it can be Linux as well. And that's what we call Linux containers on Windows. Then here, like in orange, you can see that you have the Windows kernel, similar that I was showing before, where you have that host container service. That's the container service I was talking on the previous slide. If you compare here, see, that's the compute service, the container management. And that's what they call host container service. That thing here can create the container using Container D now. We don't even need Docker anymore, but we run containers here. If you want to run Linux containers inside the Windows kernel, what we do now, okay, we create like that lightweight VM that we call utility VM using that guest container service, where we have a dedicated Linux kernel inside that utility VM. And that should be the same, going to run C in the container, very similar to what we have here.
Yes, this is like an automatic process. If you do like a Docker run it like Alpine, you will spin up in your Windows a Linux container with this underlying VM. This is transparent for the user, right?
It is transparent. Yep. Once you say Docker run on Windows, they're going to get that, and they're going to create. Let's run Nginx. That's like web server. That's a Linux one. And if I put for 85 and say Nginx 2, there you go. I was using port 83, Fernando. Then I go here, open my browser. There you go. I have Nginx. And look, that's Windows containers. That's not Linux containers, okay? That's my Linux container here. I don't have Linux container running. I have just Windows containers. But there's a Linux container running inside the Windows container feature on Windows 10 and Windows 7. Okay, that's quite interesting. People get confused on that, but let's try to understand here. If I go here, Docker PS, you can see that I have both running. Okay, I have Nginx 2, and that's like an Nginx version. That's a Linux image. But if I do a Docker inspect on that container here, let's see what that container here can see the information about the container. And you can see there's Nginx, blah, 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 platform Linux. See that, Fernando? And you see the driver, LCAL, you call Linux container on Windows. And you can see the platform is Linux, okay?
Okay, this is nice. Now we can use the same Windows server to run Windows containers and Linux containers. This is great. This is a great thing.
This is great, and I haven't tried yet, but let me try do a CLI here. And there you go, look at this.
Oh,
That's Linux, okay? That's my Alpine. Oh, that's my Nginx.
inject, yeah.
Interesting, that's what you call Linux containers on Windows, okay? And if I go one step further here, on Azure, we have something called Azure Container Instance. That's like a serverless container, where now we can run Windows and Linux containers as serverless. And that's, the infrastructure that we, Microsoft, provide, They run exactly like I was showing. They have a Hyper-V, and they run all your serverless containers on top of that Hyper-V. They're not even using Docker anymore. They're just using Containerd. And they have this utility VM, like I was showing before, the guest container service for Linux containers, and the normal container service for Windows containers. Then the same thing that you run on Azure Container Instance, you can run on your machine now, okay? And you can see Linux containers on Windows, or what some people are calling Windows containers on Windows. It's funny, but it's kind of a way to separate and people to understand that we can run both things. And just to finalize, Fernando, that's how Containerd works, okay? Containerd is that high-level library where, like, Docker can talk, and Microsoft Cloud, other clouds can talk with that high-level library that creates the container and talk with the container's runtimes. The container runtime for Windows container is called RUN HCS. That's host container service. We call RUN HCS. Just because the Linux version is RUN C, we call RUN HCS. There are others that can do similar to Hyper-V in isolation, like Kata containers or GVIs or Firecracker, okay? Not going details here, but is a subject for a single presentation or a single talk, just to talk about Containerd and explain how they manage the container image, okay, the container, the namespace, the snapshots. It's very interesting to learn how that works under the hood. I think that's the main thing, Fernando, about Windows containers. If you want to modernize your application, start going deep on that and try to understand. I was just want to show, we're going to show that GitHub here called eShop Modernizing. It is a little bit out of date. We're going to, during this series, try to do some pull requests and update that thing that's done by Microsoft architecture team, where you can get a full .NET application and modernize, even deploy on VMs or Kubernetes on Docker, okay, on Docker for Windows. And let's see, it's a little bit, there are things done 5 months ago, but let's see how we can use those samples. Even a book explain how to do that. And I recommend you to look on these and look on those links. There's a few links here that you can look. Elton is a former Docker and is a Microsoft MVP. You can see Stefan Scherer from Docker. There's very interesting links here. There's a link from ACI where that slide was presented. You can go on that video. And that slide, I'm going to finish with that slide, and that's exactly what we just showed, where Visual Studio is doing all that process for us. Look at that, Fernando, all that process here, getting your code, building the image, and running your image is all done by Visual Studio.
Yes,
but you can
by Visual
automate
Studio
that,
or a pipeline.
Or a pipeline. Maybe you can do a pipeline to show that here automated.
Yeah, thank you so much for sharing that, but there is no questions. The thing I'm seeing, like Microsoft made containers much easier for Windows developer than it used to be to Linux developers, because it's almost everything is automated by Visual Studio.
Exactly. And people using full .NET framework, they have access to Visual Studio. And that will be the first step, then modernize and trying to move to .NET Core, if that's the case, because you don't have to. Okay, we're going to see you next video. We're going to try to go a little bit deeper on that, using shop containers as an example, and how to really get an application and move to.
So for that, subscribe at Azure and activate the notifications to know when we post our next video. Thanks, George.
Thank you, everyone. Nice background, Fernando, by the way. See you soon.
Thank you.
Bye-bye.